Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 18 of 24. If an LLM request takes 10 seconds, is the AI provider slow, or is your proxy's event loop completely choked? You cannot fix a bottleneck until you know exactly where it lives. Prometheus metrics and pod health in LiteLLM give you that exact visibility. LiteLLM exposes a standard metrics endpoint at the path/metrics. A common mistake when monitoring AI gateways is treating all response delays as LLM provider latency. That is inaccurate. There are two distinct waiting periods. First, there is the pre-ASGI queue latency. This is the time a request spends waiting inside your infrastructure before the proxy even begins processing it. Second, there is the actual LLM latency, which is the time spent waiting for OpenAI, Anthropic, or another provider to return tokens. The metrics endpoint separates these numbers, so you know exactly who to blame for a slow response. To monitor your pod health, you rely on a specific gauge called LiteLLM in-flight requests. This metric tracks the exact number of concurrent requests actively being processed by a pod at any given millisecond. This is a real-time measure of queue depth. When traffic spikes, this number climbs. Consider a concrete scenario. Your monitoring dashboard shows a massive spike in total request duration. Users complain about slow answers. If you only look at total time, you might assume OpenAI has an outage, but when you check the metrics endpoint, the provider latency is stable at 2 seconds. Here is the key insight. You look at LiteLLM in-flight requests and see it has skyrocketed from 20 to 200. This proves the delay is not OpenAI. Your pod queue is completely overloaded. Armed with this exact gauge, you can configure your infrastructure to trigger an autoscale event the moment in-flight requests cross a specific threshold, spinning up new proxy pods before the event loop chokes. You also need to know who is generating this traffic. LiteLLM supports custom Prometheus tags. When a request hits the gateway, you can pass custom metadata in the request payload, like a project ID, a department, or an application name. LiteLLM extracts these custom tags and attaches them as labels to the Prometheus metrics. Instead of just seeing that the gateway processed 10,000 tokens, you see that the marketing application processed 7,000 tokens and the analytics dashboard processed 3,000. This gives DevOps the ability to group token usage, queue depth, and latency by specific tenants. The most critical takeaway for gateway performance is this. Never autoscale your AI proxy based on total response latency, because you will waste money scaling up when the external provider is simply being slow. Scale based on your in-flight request gauge to react only when your own infrastructure queue is actually full. Thanks for listening. Happy coding, everyone.